Hello students, welcome to Educate. We are going to continue with chapter Waves, class 11th physics. So in previous lecture, we have studied about basics. Now we are going to continue wavelength and angular wave number. So the relation that we have studied, that is y x t a sine kx plus omega t plus phi. Here we are making some assumptions that phi equal to 0, t equal to 0, then we get this relation y as a function of x0, a sine kx. Since the sine function repeats its value every 2 pi change in angle, so sine kx equal to sine kx plus 2n pi we can write, or we can take out k from here, then 2n pi divided by k we write. So sine k x plus 2n pi divided by k. So that is the displacement at point x, and at x plus 2n pi upon k are the same, where n can be any number, any natural number like 1, 2, 3, 4. The least distance between 2 points with the same displacement at any given instant of time is obtained by taking n equal to 1. So we get lambda is given by lambda equal to 2 pi by k, or k equal to 2 pi by lambda. Here k is called propagation constant, right? And k is also called angular wave number, and its unit will be radian per meter or radian meter minus 1. Up to here, I don't think that there is problem. Now we are going to see next point, period, angular frequency and frequency. So as we have seen earlier, the equation here we are putting x equal to 0 and t will be there. So we get this equation, a sine minus omega t. We take this minus sign outside because sine minus theta gives minus sine theta. So minus a sine omega t. And then we write this, the period of oscillation of the waves is the same, is the time it takes for an element to complete one full oscillation. So we just write minus a sine omega t equal to minus a sine omega t plus t, where t is period. Or we can take this omega inside, so it becomes minus a sine omega t plus omega capital T. Since sine function repeats after every 2 pi, so we can say omega t equal to 2 pi or omega equal to 2 pi by t. Here omega is called the angular frequency of the wave. Its SI unit will be radian per second. The frequency nu is the number of oscillations per second. This thing you have already studied in lower level also. So nu equal to 1 upon t or omega upon 2 pi. Nu is usually measured in hertz, that you have studied. Now here we are writing the equation. The displacement function for a longitudinal wave is written as xt, means x is function of x and t, and it's given by a sine kx minus omega t plus phi. Here sxt is the displacement of an element of the medium in the direction of propagation of the wave at position x and time t. Right. Now further, let's consider one question. You are given example, a wave traveling along string is described by y as a function of x and t is 0.005 sine 80x minus 3t, sine kx minus omega t, a sine kx minus omega t, right? Here all things are taken in standard units, so we can easily calculate amplitude, wavelength, period, etc. And then we have to find out the value of y also when t equal to 20 seconds and x equal to 30 seconds. So we can put these values here. Question is simple. So let's consider one by one. So first of all, we write the equation y equal to a sine kx minus omega t, and we make comparison with the given equation. So what do we find? Here a is equal to 0.05 meter. Then k is 80, k equal to 2 pi by lambda. So from here we can calculate lambda, and omega 2 pi by t is 3. So the same thing is given here. The amplitude of the wave is 0.005 meter or 5 millimeter. The angular wave number k is 80 and omega is 3. Now, if we write lambda equal to 2 pi by k, that we know. So we have value of k. So we write it here, 2 pi by 80. So lambda we get 7.85 centimeter. Right. Now, next point is we have to find out time period. So for time period, you know t equal to 2 pi by omega. In our question, omega is given 3. So just write the value. So we get 2.09 second. And then we have to find out what is frequency. And you know frequency is 1 upon time period. So 1 upon t. So it comes out to be 0.48 hertz. Now, the last point is we have to find out displacement equation when value of x and t both are given. So, displacement equation, as you have seen, it is this y xt 0.05 sine 80 x minus 3t. So, here x is given as 30 centimeter. This all is in SI unit, so we can convert it in SI unit. And time is 20 seconds, we write here. So we get the relation y equal to 0.005 m sine 80 into 0.3, that is x, then 3 minus 3 times 20. So it comes out to be 0.005 sine minus 36 plus 12 pi. And we further simplify, so it comes out to be 0.005 sine 1.696, and this value, this becomes 97 degree. Correct? So you can evaluate it properly by using calculator, that will be better. And don't rely on this calculation, right? You have to evaluate this, and then you will take sine of that value by using calculator, you will reach here. Correct? Now, the speed of a traveling wave. So here we consider a wave traveling like this. There are two waves. So the shape of the wave at two instants of time which differ by a small time interval delta t. The entire wave pattern is seen to shift to the right positive direction of x by a distance delta x. So we are considering a time t. So this one wave, then it moves through certain distance. Then two situations we are considering here. These 2 points are in same phase. This is delta x. Time gap is t plus delta t. Correct? So here in particular the crest shown by a dot moves a distance delta x in time delta t. That is very obvious. The speed of the wave is then delta x by delta t. We can put the dot on a point with any other phase. The point should be on same phase. It will move with the same speed v, otherwise the wave pattern will not remain fixed. The motion of a fixed phase point on the wave is given by, so we are considering the phase. Phase means angle, and we write it as constant kx minus omega t equal to constant. Now there are two possibilities. This equation can be differentiated either with respect to t or with respect to x. So let's see that as time t changes, the position x of the fixed phase point must change so that the phase remains constant. So here kx minus omega t equal to, here we are changing x to delta x, and similarly time t plus delta t. Or we can write, we cancel this kx etc. So k delta x minus omega delta t equal to 0. This is done without using differentiation, just we have taken the changes, means x increases from x to delta x and t increases from t to delta t, right? So we get this relation. Or we can convert delta x and delta t into dx and dt when the values are small. So in that case we get dx upon dt from here is omega upon k, that will be wave velocity. So, and we know v equal to 2 pi nu divided by 2 pi by lambda, that gives lambda upon t. This is basic relation that you have already studied in lower level. Now, we are going to see next important point. Here, speed of transverse waves on stretched string. So, in case of a stretched string, what do we need? We need tension and mass per unit length. So, here nu equal to c t is t divided by mu is given, and about these things here, mu is mass per unit length, t is time, t is tension is force. So we get this relation. Final relation, we can write speed of transverse wave on a stretched string as v equal to t upon mu. So keep in mind while calculating the speed here, this mu indicates mass per unit length. So you have to divide it. So unit of mu will be kg per meter, right? So here we are going to see one question based on this concept. A steel wire 0.72 meter long has a mass of 5 into 10 power minus 3 kg. If the wire is under a tension of 60 Newton, what is the speed of transverse waves on the wire? So as you have seen that speed of transverse wave is given by v equal to root t upon mu. So all that we need mu. So mu is mass per unit length. Here mass is given as 5 into 10 power minus 3 and length is given 0.72. We write this value here and then we simplify. So we get 6.9 into 10 power minus 3 kg per meter. And tension is already given 60. So speed we can find by putting the values in equation v equal to root t upon mu. So t is 60 and mu we have got here this value, and then this comes out to be 93 meter per second. Now we are going to see another thing, speed of a longitudinal wave, speed of sound. So Newton's formula. So in case of Newton's formula, we assume that there is wave propagation, but change is isothermal, right? So if we consider isothermal change, here we are considering bulk modulus and we write the relation, then relation comes out to be v equal to bulk modulus divided by density, right? And there is another relation also in terms of Young modulus divided by density. But this relation has certain drawback that we will see. So here we are going to see the same thing. Here expression is given that v is equal to p upon, here what we have derived, v equal to b upon, b is bulk modulus divided by rho. Later on we establish it that p equal to b. So here in place of b we write p, pressure. So v equal to p upon rho, and then we can put the values and we will try to get the result, and this result will not match with the practical value. Here if you wish to see why p equal to b, so we can do it easily. We can estimate the speed of sound in a gas in the ideal approximation. Sorry. For an ideal gas, the pressure P, volume V and temperature T are related by PV equal to N kBT or PV equal to RT. Here N is Avogadro's number, K is Boltzmann constant and T is temperature of the gas. So here we can differentiate it. So if we differentiate, so V delta P plus P delta V, in RHS everything is constant, so that will become 0. Here product of two functions we have assumed and then we have differentiated. So we get P equal to delta P divided by minus delta V upon V. And this term, as you have already studied, that it is equal to bulk modulus. So you have got bulk modulus equal to pressure. So in this formula, you can write V equal to P upon rho. Now, this relation is called Newton's formula for speed of sound. But let's calculate whether this value is correct, means this relation is correct or not. So here there is one practical question. Estimate the speed of sound in the air at standard temperature and pressure. The mass of 1 mole of air is 29.0 into 10 power minus 3 kg. So this is information, and now we are going to evaluate the value of V. So we know that 1 mole of any gas occupies 22.4 liters at STP. STP means standard temperature and pressure. Therefore, density of air at STP we have to find out, because in this formula we need pressure and this density. So mass of 1 mole of air divided by volume of 1 mole of air at STP. So mass is given, volume is given. So density we get 1.29 kg per meter cube, and you know that atmospheric pressure is equal to 1.013 into 10 power 5. So those two values we are going to put here. One, that of rho 0, here in place of rho we will write this value, and pressure we will write. So what do we get? So on putting the values, we get V equal to 280 meter per second. This value is around 15% less than the practical value. So this relation, the assumption that we have made that whenever wave propagates, then there is isothermal change, that is not correct, right? Actual value is almost 331 meter per second. So now we are going to change the concept, and this was suggested by Laplace. So Laplace told that whenever wave propagates, then instead of isothermal change, we must consider it as adiabatic change. In case of adiabatic change, the expression will change. Earlier we have assumed PV equal to RT. Here we will assume that PV power gamma. Gamma is Cp upon Cv equal to constant. Then again we differentiate it. So here when we differentiate, we get value of B adiabatic, means bulk modulus for adiabatic will be gamma times P, right? So here this is additional term. Earlier what we have got? We have got B equal to P only. So our formula modifies to V equal to gamma P divided by rho. Now we put the values. Gamma we can take 7 by 5, and P, as we know, that 1.013 into 10 power 5 divided by density 1.29, and V evaluated. And this value comes out to be 331.3 meter per second. This suggestion was given by Laplace, so this relation is called Laplace correction. So you have to remember, this question is generally asked in exam. So I think you have understood it fully. Other concepts we will study in next lecture. Thank you for watching. Team Educate.